Hello everyone. In this video, we are going to talk about the Dynamic Host Configuration Protocol, well known as the DHCP. So as a network engineer, this is one of the most important topics that you must be able to understand properly. So by the end of this session, you should be able to explain what is a DHCP is, and you should also be able to configure a DHCP confidently in your network. So first of all, you have to understand what is a DHCP. So DHCP is a client server based model structure, so where we are going to have the client and also we are going to have the server. So as we are speaking right now, as you are watching this video at this moment, you are using it. That is, you are using the DHCP, meaning you are using your IP address to connect to your internet, and the IP address we are talking about, you are obtaining is from the DHCP server. So the DHCP server is what assigns the IP addresses you are able to use to connect your node to the internet. The node I'm referring here is the phone you are using or the laptop you are using. So as you can see in this diagram here, I have got the DHCP client on this side and the DHCP server on this other side. So the DHCP client and the DHCP server, they should be able to exchange the messages with each other. So the DHCP, the reason why we implement the DHCP is because initially back then, when the networking, during the early days of networking, IP addresses were used to be assigned manually. That is the static assignment. But the problem with the static assignment is that as the network increases, as the network enlarges, it becomes so difficult to assign each and every device an IP address manually. Like for instance, let's say you have 1,000 clients in your company. Like you have 1,000 people. So you won't have to go to every device, every individual to sign an IP address manually. That one will become very tedious, and that's why we implemented what is called DHCP server. The DHCP server, it's a dynamic host protocol. The client, once you've configured the pool where the devices obtain the IP addresses, the client will now just request for the IP address and obtain it dynamically. So with the DHCP, we have got the messages types that are used to be exchanged between the client and the server. So there's always a formula that is always used, that is called the DORA formula. The DORA formula, where the DORA here, the DHCP D here stands for the DHCP discovery, DHCP discovery. Let me just use the discovery. So this one stands for the DHCP discovery, and O here stands for the DHCP offer. R here stands for the DHCP request. Then A here stands for the acknowledgement. Now, the client, first of all, when a client connects to a network, the first thing it will send, the first message it will send will be the discovery. When a client first connects to your network, it will send a discovery, and it is sent in a broadcast form, so discovery. And this discovery message is in a broadcast form, broadcast. It will broadcast the discovery message to the network. So in case there are several DHCP servers, so when it sends the discovery, several DHCP servers will receive this message. Then the DHCP server will reply with the DHCP offer. And the DHCP offer, this is a unicast because it is from the server to the client direct. This is a direct communication. But when the client sends the DHCP discovery, it broadcasts it because it doesn't know which DHCP is in the network. So any DHCP when should receive this discovery message. So once after sending the discovery message, the server will reply with the DHCP over, which is a unicast. Is a unicast 1-to-1. After in the DHCP offer message, which is a unicast, it carries the configuration parameters. After the client receives the DHCP offer, it will now request for the IP addresses. So request for the address requests. So it sends a DHCP request to a request for the IP address. With the DHCP request, it is also a broadcast. Also a broadcast packet, a broadcast message. It'll send a DHCP broadcast message so that any of the servers can allocate the IP addresses. Then after the server has received that IP address, it will now send the DHCP of acknowledgement. Like it will acknowledge, okay, this is the IP address you want. Now you are allowed to use this IP address. So the DHCP server sends what is called acknowledgement. It acknowledges the client to be able to use that IP address. So the acknowledgement is a unicast because it's the server sending directly to the client. So this one is a unicast packet. That is one-to-one communication. So those are the messages, but it is not only those two messages. There are also other messages. We have got the DHCP, the DHCP decline, the DHCP decline messages. DHCP decline message. We have got also the DHCP NAC. The DHCP decline messages. This is sent by the client. Now the client sends the DHCP decline message to decline an IP address. Let's say, for instance, the server has allocated an IP address to a client, but the client finds that this IP addresses conflicts with another IP address. It will send a DHCP decline to the server. So this one is sent by the client. It sends that IP address to the server to tell you that that IP address conflicts with another IP address, so it cannot be able to be used. Another thing also, we have to send there's also another message that is called the DHCP NAC. So the DHCP NAC is sent by the DHCP server to DHCP server to reply the client. The DHCP NAC is sent by the server to reject the DHCP request made by the DHCP client. For instance, let's say the DHCP client has requested for an IP address. Then you find that in the IP address pool, all the IP addresses have been used. There's no any idle IP address. There's no IP address that can be assigned to the DHCP client. So therefore, the DHCP server will reply with the DHCP NAC that hello client, I cannot assign you any IP address. My IP address pool has been depleted. Then there's also what is called the DHCP offer. This DHCP offer, this is a message sent by the DHCP client. So this is for sent by the client to request for the service for other configuration parameters, including the DNS, the DNS server address, the subnet mask, and also the gateway, the default gateway. So this one is sent by the client to the DHCP server, requesting for the DNS server address, gateway, and also gateway and the subnet mask. Those are the the messages. So these are the DHCP messages. So they are like DHCP messages. There are so many. So we have got like 6 of them. We have got like I can say there are 7, but the main DHCP messages are the discovery, offer, request, and acknowledgement. These one are the ones that you'll be able also to see. There are supposed to be 8 the 8 messages. There's one I'm leaving out here that is called the DHCP release. There's the last one. We have got the DHCP release message. The DHCP release message is sent by the DHCP client to release the IP address. Let's say the IP address, the client has used the IP address and it is done with what he was doing with the IP address. It can release it back to the DHCP server so that the DHCP server can now assign the IP address to a different node. So this is sent by the client to release the IP address that had been assigned. So that is about the DHCP messages. So we also have what is called the DHCP status. The DHCP status here include the status can be the IP address has been used, the IP address it is idle. Used an IP address that has been used, where the status indicates that it is used, is the IP address that has been signed to a device. Idle means that the IP address is still in the pool, but it has not been assigned to any device. Expired means that the IP address was assigned to a device and it has expired. Also, there is something that is called the lease. The lease. DHCP lease. So the DHCP lease, this is the time a device is given, the time a device is allowed to use that particular IP address. Time a device uses an IP address. Let's say, for instance, you sign into a network, you'll be given an IP address, but this IP address is not given permanently. You'll be leased, meaning that you'll be given for some days. Let's say you can be given to use that IP address for 1 day or 2 days. The reason why we use the lease, this is help us in case the pool IP address has been splitted. When one of the devices that has been connected leaves the network, the IP address can be assigned to a different network. Let's say, like here in our topology here, we have got 4 of the PCs. So let's say even in our DHCP, the DHCP could only sign 4 IP addresses permanently to these 4 networks. And you say this PC1 here, it came and only used the network for only 2 hours, then left the network. After that, it leaves permanently. It never comes back to the network. So that IP address will goes with that PC. When another device comes into the network, it won't be able to connect to that network because that IP address that was signed to that device, it was signed permanently. So when it tries to renew request for an IP address, the DHCP will reply with the DHCP NAC that the IP addresses have been depleted. So that's why we configure a DHCP list to that only give a device an IP address for a period of time. So when that time elapses, the IP address is said to have expired. Let's say if the 2 days elapse, it is expired. But during the lease, it is required that the client should renew for an IP address when the IP address, the time that has been set has reached the half of the, let's say it is 2 days. After 1 day passes, the DHCP client should renew for an IP address because in case the DHCP client doesn't renew for an IP address, the DHCP server will reallocate another IP address, a new IP address. But it's good now when you renew, you are being relocated the same IP address that you have been using. So that's about the DHCP list. So once the time has expired, the state it enters the unexpired state. So that's the second state. So we started with the used state, the idle state, and the expired state. Then the conflict. Like I said, in a conflict, like for instance, there are two ways in which you can experience the DHCP conflict. DHCP conflict. So a DHCP conflict happens in this way. In the first case, when the DHCP client sends the DHCP discovery to the DHCP server, the DHCP server will send a ping packet. The DHCP server will send a ping packet, and when it receives a ping reply, it will know that there is an IP address. When the ping packet goes successfully, it should know the status is there's a conflict status, meaning that there is a device having an IP address there. As it replies with the offer, before it replies with the offer message to assign the IP addresses to the client, it will first send a ping packet. And when that ping packet succeeds, it will know that there is a conflict in the network. Also, it's the same scenario. Also, the DHCP client will send a gratuitous ARP to the DHCP server. When it receives a response, it will know that this IP address has been located to someone else. So it will change the status to conflict. So after changing the status to conflict, it will now request for a new IP address from the DHCP server. So the DHCP server should be able to assign a new IP address to the client. That's how that thing works. So after that, there's something that is the parameters. So we have got the parameters. The DHCP server does not only sign the IP address, but it also signs the subnet mask, the DNS server address, and the default gateway. The DNS server address just gives you the domain name of where you want to access. And then there's also something called the DHCP binding. Like for instance, you want to ensure that the IP address that has been signed to that client, let's say your phone or your computer, it stays permanent, so that every time, even if the lease expires, you still have that IP address. Like for instance, let's say devices like the printers will require a permanent IP address. So what you do, you will bind the IP address to the MAC address. Also the routers will be running throughout in your network, so they require a permanent IP address. The same to the servers. You have to send the permanent IP address, and the only way you can send them IP addresses is through the binding the IP address to the MAC address of the actual device. Then also you always set our IP address based on address pool. So there are two ways we can set our IP address: interface pool or the global pool. When you set the interface pool, only the device that has been connected to that interface will be able to acquire an IP address. But for the global pool, which is created in the global view, in the system view, all the devices that has been connected into that network will be able to obtain an IP address. So guys, the DHCP client here, as I said, the DHCP works on the client and the server base. When the DHCP client sends an IP address, it uses a UD port 68, as I've just showed here. So it uses a DHCP client UD port 68. While when the DHCP server replies, it replies with the UDP port 67. UDP just stands for User Datagram Protocol. So the DHCP is a user datagram protocol. So that's the theory behind the DHCP. So first of all, the most important thing is you must be able to understand what DHCP. How does DHCP works? There's also something called the DHCP relay. How does the DHCP relay works? For instance, like here, you see here, this is a DHCP. This is a DHCP client. This is a DHCP server. You can also bring a DHCP relay agent. So that this switch here, it will act as our relay agent. Let's put this one here and like this one here. So this switch here will act as the DHCP. This one will act as the DHCP relay agent. What do I mean by saying the DHCP relay agent? Like you find that the DHCP client here is on a different network with the DHCP server. Now the DHCP relay agent will relay the message, the discovery messages from the DHCP server and the offer messages, the discovery message from the DHCP client and the offer message from the DHCP server. So it will be able to link these two, the client and the server. When the packet gets to the DHCP relay agent, it modifies that packet, like let's say the discovery or the offer packet, it modifies that packet before it sends it to either the DHCP client or the DHCP server. So that's the theory part of the DHCP. I hope you've grasped something, so that when we go and configure the DHCP, and we capture packet from using our packet capture, you should be able now to see this thing working. So that's the point. That's the point of the theory. Now I'll just remove these parts here. I'll just remove those parts, or I can move them down here. Then this one here, I shape it there. This one I can remove. Let me remove this one. And now bring our device close and now implement the theory part. Now theory and practical, when integrated, it's just a higher level of understanding. When you understand the theory and now you can implement it in terms of practical, then there's nothing you won't be able to understand in networking. Networking is very easy, but the most important thing is you should be able to integrate between the theory and the practical. Most important thing, know how you can do the practicals. So this is the practical we are going to implement. We're just going to configure the DHCP server, and you're going to see how the DHCP server are going to exchange the messages. The client and the server are going to exchange the messages. So our router here will act as the DHCP server. The router will act as the DHCP server. Then Then this PC down here will act as the clients. So enter into that your router as usual. You undo the terminal so that during your configuration you don't get those distractions. Then we change the device name, say this is router 1. Name router 1. Come to this switch and do terminal UTM. The ATM. We change the device name. This is switch 1. The switch 1, we are going to create two VLANs. So that is VLAN 10, VLAN 10, and VLAN 20. VLAN batch 10. VLAN batch 10 and 20. After creating the VLAN batch, we are going to configure now the interfaces. These two interfaces are going to be given default interface of gig of VLAN 20. This one VLAN 10, VLAN 20. Then gig 1 here is going to forward VLAN 10 and 20. So interface gig 0/0/1, port link type, this is a trunk port, then port trunk allow pass VLAN 10 and 20. Quit. Then gig 2 interface gig 2 port link type here, port link type, this is an access port because it connects to the terminal, that is the end user. The port link type access, then the port default VLAN. I'm going to give it the port default VLAN 10. Also gig 3 here, we are going to give it port default because it is an access, port link type access, then the default VLAN 10. We do the same to gig 4, port default link type, this is an access port, it's a terminal device. Then tell it to give it a default of VLAN 20, and the same you do to gig 5. And gig 5 also, this is an access port. An access port, you give it a default VLAN of VLAN 20. Then you quit. So we are done with the layer 2 there. So switch 2 here was just acting as layer 2, just forwarding. Then now we are going to configure now our router. Our router here, we are going to configure the .1 queue termination because we have got gig .1 and .2, but we have only one interface, but two sub interfaces. These sub interfaces are the ones that are going to act as the default gateway for the two VLAN 10 and VLAN 20. So interface G0/0/0/1.1 /1 .1 queue termination. You undo .1 queue termination VID 10. Then after that you give it IP address of 192.168.10.254/24. ARP broadcast enable, and this display this and let's see. We've enabled .1 queue termination. We've also configured an IP address on the ARP broadcast. We've enabled a broadcast. Then gig .2, we're going to .2. Here we are going to undo termination. .1 queue termination, that is VLAN 20. Then IP address of 192.168.20.254, then the subnet mask of 24. So hey, we are configuring the DHCP server, and the DHCP server, we've enabled the DHCP. After that, we create the DHCP pool, say IP pool, I give it pool 1, and pool 1, I set the network to be network of 192.168.10.0 mask of 24. After that, we set the gateway list. Gateway list will be 192.168.10.254. After the gateway list, you also set the DNS list. The DNS list also is set to 192.168.10.254. The next thing is set the list, the list time, the time period for which the devices will be able to use that IP address. So the list is set to 3 days. Display this. So list day is set to 3 days, and the network is 192.168.10.254. Let's create the pool 2 for the VLAN 20 devices. So create. I want to create for pool 2. So pool 2, the network will be 192.168.20.0 mask of 24. After that, set the gateway list. The gateway list will be 192.168.20.254. That's the .254. Then the DNS list. DNS list will be 192.168.20.254. Then the list day is set to 3. Display and see if what have been configured. After that, you quit, and now you enable the DHCP in the global view. That you enter the interfaces, the sub interface. Then you enable the DHCP in the interfaces. So interface gig 0/0/1.1. Tell it the DHCP global. The DHCP select. I tell it to select global. So we also enter for gig and display one. See what is on that interface. You can see that. Then you enable the DHCP. So DHCP select. You tell to select global and quit. For that I have to display DHCP statistics, display DHCP server statistics. There's no IP that has been assigned, so alright, we didn't select the DHCP on these devices, so let's select the DHCP. Let's also select on this other guide. Let us enable them. They were in the static view, but here I want them to select from the DHCP view. So when you select the DHCP, so you select the DHCP button and see. You see, it's now able to obtain an IP address of this one, 192.152. Then this other guy, say IP config config to see if it can obtain an IP address. So it has obtained an IP address of .52, and this other guy, IP config .52. So the reason why it was not able to obtain that type is because we didn't enable the DHCP on the client side. So let's capture packet and see how our packets are being captured. So when we try to capture packet on that interface of gig, gig 0/0/1, this is what happens. These are the DHCPs being packets are being exchanged. So initially the client here broadcast on 255.255.255.255. It sends the DHCP discover. It's a broadcast, as you can see here. Then after it sends the DHCP discover, the server now reply with the DHCP offer to offer an IP address of 192.168.20.253. This is the IP address of the DHCP server is 192.168.20.254, but it applies to offer an IP address of 192.168.20.253. After now the DHCP offer has been received by the DHCP server, the DHCP client, the DHCP client now send a DHCP request. So you see the DHCP request is also a broadcast of 255.255.255.255. I send the DHCP request to the DHCP server to request for that IP address. When the DHCP server receives this, it replies the DHCP acknowledgement. As you can see here, the acknowledgement is 192.20.253. That is the DHCP that it has been offered by the DHCP server. It now replies, okay, you can now use that IP address that we wanted to use. So that's how the packets are being exchanged. That's how, like, you see how the DHCP is negotiating with the DHCP client. The DHCP server and the DHCP client are negotiating. Then there's also called the gratuitous ARP. The gratuitous ARP here is sent by the DHCP client in case there is anybody using that IP address on that network. Should be able to cap the conflict that if somebody else is using that IP address, it should send a gratuitous ARP say that that IP address conflicts with another IP address. So that's how we set a DHCP server. So now we are going to display DHCP server statistics. DHCP server statistics. When you display DHCP server statistics, you see here the client requests are 8. Then the DHCP discover 4 DHCP discover has been sent. and the DHCP requests are 4. DHCP decline, there's no any IP address that has been declined. The DHCP release, there is no device that has released an IP address. Then DHCP inform, this form they have not given the parameters like the DNS. The DHCP server reply 8, and the DHCP offer has been R4. DHCP acknowledge R4. There is no DHCP NAC. So that's the implementation of the DHCP. So DHCP display DHCP statistics. So that is how it happens. DHCP request are 4 and the DHCP discover are also 4. So I hope you guys you've understood how you can do your configuration of the DHCP to enable that all the DHCP are able to work. Let's see if this guy can ping the other network on the other. So ping on the different VLAN, ping 192.168.20.252. Yeah, it's be able to ping, because we enable inter-VLAN communication on the router by configuring the sub-VLAN interfaces. Gig.2.2 so on that interface of gig 1.2, let's display and see.